So good morning, good almost afternoon, everybody. My name is Joe Oligny. I am head of sales operations for PacketFabric. That includes sales engineering, solutions architecture, as well as our client success teams. I'm joined with my colleague, Chris Teeluck, who oversees our partnerships. And today, we're here to talk a little bit about software-defined networking and where we're going with it, how it is advancing, how it fits into the carrier world, and why it might be important to you guys. So before I do that, a little bit about PacketFabric. We are a layer 2 network transport provider. It's secure, doesn't touch the internet. It's completely backed up and automated by our own intellectual property, our software-defined orchestration network. And our customers typically use us to deploy between data centers, a data center like this to maybe downtown or to Ashburn. Maybe they're doing it to get to the clouds. We have Amazon here, but maybe they need to get to Google. Or business partners that are located across town or across the country. And for us, as John said, we're now international. We're in London, pushing out to Frankfurt, Amsterdam, Paris, and going into. Hopefully by the end of the month, we will have a pop-up in Sydney, Australia. So we're growing at the speed of the internet, but we're not the internet. Is everybody familiar with the term SD-WAN? Software-defined wide area networking. Typically, it allows our remote offices, our offices in multi-tenant buildings to leverage a box, an IPsec tunnel, whatnot, to connect to their other locations without going through a long, lengthy private line thing. We're not SD-WAN. We're more the middle mile. SD-WAN is kind of last mile. We're the middle mile where you're connecting data centers to clouds, data centers to data centers. Anywhere from 1 gig to multiple 100 gigs. Right? This is all driven by automation. Right? Get the humans out, let the system do it. And the automation we see today, we've seen over the past couple of years with the rise of SD-WAN, whatnot. It's all got its roots way back when. Used to be network folks would write shell scripts or whatnot to automate their jobs, to get on with the more interesting things. They would do it to prevent errors in configurations, streamline it, make things faster, right? Because at the end of the day, networks, what's the point of the network? The network is there to support the people and the applications. The people and the applications support the business. Business brings in money. So you fast forward to today, automation is key. It's what allows folks to deliver things faster, take advantage of changing market, get ahead of their competition. First to market definitely has an advantage. So much so that we're seeing all the hardware vendors in the network space. Your Juniper, Cisco, Arista, Dell, Huawei, others. They're now shipping orchestration, automation type enablements, right? So here's just a couple for Arista. They call it their Cloud Vision, right? It's just a kind of a pane of glass where you can naturally type in what you want, and it abstracts away all the hard stuff. Cisco's got their new crosstalk network automation. It's an evolution of their ACI product. Juniper, on their JunoOS, they've got Contrail. These are all automation, deployment, configuration, orchestration engines. Why are all these manufacturers jumping on the bandwagon? It's because it's what the market is driving. If you look at U.S. Bureau of Labor Statistics, you look at network engineering as a profession, its growth is steady. It's projected to be steady. You look at software development, it's outpacing everybody else. This is important. When you combine the two, you get this new concept called net DevOps, where you have network engineers treating the network as code, as software development. They're interacting with the network, they're deploying the network, they're managing the network as if it were code, as if it were, some application, underpinning their website. This is what it might look like. In this particular instance, we've got a couple of hosts. We got an environment on the West Coast out in California, one in New York on the East Coast. And treating the network as a code, they run a script and it deploys a pathway between the hosts. To show you, how fast, little timers here. It takes about 15 seconds. Now, if we were to do this manually, the old way, the legacy way, It's a big project. I need to do this. I got to start a project for it. I got to get a project manager. I've got to get network engineers. I got to put a ticket in. It gets built, goes back and forth. It takes time, a couple days to a couple weeks to, so I've seen some cases a lot longer. When you treat the network as code, you use software-defined networking and automation and orchestration. This is now deployable, the same as if you were to download an app and start something, just real quick. In the legacy model, before I go in the legacy model, right now, folks are using these tools to orchestrate and automate within their environments, right? Within their enterprise networks, within the data center space, the remote offices. But when you got to connect the two, right? Connect two data centers, whatnot, you go out and you work with, point-to-point services or MPLS services, and you've got to go through the traditional process of putting that in place. And then once that's in place, then you can get, Office A or Data Center A talking to Data Center B, and you can overlay your automation, your orchestration on it. But the middle mile, as we call it, is still, for the most part, done the old-fashioned way, right? A lot of legwork, a lot of project management, super urgent, pants on fire. You might see it go up in 14 days. It's not uncommon, and I'm not doing this to smear the legacy way of doing it, but it's just the way it's built. It's not uncommon to see 30, 60, 90. We have clients come to us to help them out because it's taken 120 days to put a circuit between data center A and data center B. When you bring in software-defined networking, you let the system do it. It takes away all of those steps. The system can generate and give you an interface. It can build a circuit. It can get you up and running in a matter of minutes without having to go through that project management phase where you got to wait for the paperwork you need to give to your data center provider to connect into the service provider. So what have you. It's all about automated control, right? Through software-defined networking, you can interconnect between your data centers. You can build additional interconnects. You can manage them either through a web portal. We're all used to using website, control platforms with Amazon and whatever have you. But also directly from your code to the system via APIs or application programming interfaces. And to put this in perspective, going back to the legacy way of doing things, let's say you've worked with your carrier, you've agreed upon a price, it's gone to a project manager, and now you got to wait for the kickoff call. They got to assign a port, and you need to order the cross connect. When you have software-defined networking in here, it can take place in a minute. You can get the port assigned and get a letter of authorization, LOA, the paper you need to give to your data center provider, in just a few moments. By the way, for PacketFabric, this is our portal, obviously, and it's self-serve, so you don't have to wait on a project manager. You don't have to wait on a team. You go in and you say, hey, I want a 10 gig port, in phoenixNAP. Give me a 10 gig port, order it, here's my description, and there it is for you. So just as fast, you've got an interface. You can have the letter you need to order the cross connect. And it's through the automation orchestration that allows this to happen. In other words, we've taken the human out of the provisioning process. So let me show you a little bit of how we do it. Obviously seen a little bit of tidbits. By the way, that little programming black screen I showed you earlier, building a pathway between New York and LA, that was actually on our network using our API. I'm not a programmer by any means, but I threw together a quick little script and was able to say, hey, go build me a circuit. I like to say, if I can do it, anybody can do it. So going back, using a fabric like PacketFabric and software-defined networking, it allows you faster time to market, allows you to take advantage of changing market conditions, get ahead of your competition. Maybe you're in a competitive bid situation, and what wins you're neck and neck, but I can deploy today. But my competition is going to take 3 weeks. Scalable for us, anywhere from 1 gig, like I said, to multiple hundreds of gigs. That's anywhere between here and 160 other locations, all data center based. Flexible contracts, we personally offer from month to month to multi-year, going up to 60 months, 5 years. You're able to connect to anybody else that's on the fabric if they give you the code or they want to accept a connection. So in the legacy way of doing things, it was called a private network interconnect. And in order to do that, you would have to go and host your network node or your operations in the same facility as the partner, right? Using the fabric, it's just a virtual circuit. You just say, hey, I want to connect to partner X that might be across town, might be in Los Angeles, might be in New York. And you get that instant on-demand connectivity. Competitive pricing, all our pricing is transparent. It's on our website. Like I said, month to month to multi-year, give you an idea. A 1 gigabit per second circuit from Phoenix to New York is like $500 a month. Okay. And control, as you saw with some of the demonstration in the portal, the control's at your fingertips, right? You get a port when you want it, not when the project manager, the legacy way of doing it, decides to give it to you. Okay. The way folks use us, again, getting between data centers, getting to their partners, getting to the clouds. We've got all the major clouds, Google, Amazon, Oracle, Microsoft Azure. We also have a slew of more specialty clouds like PacketHost, Linode, things like that. I think we just brought another one on, Vultr, who specializes in disaster recovery. Use our web portal or API, and you can get real-time statistics from the web portal, how much traffic you're doing at any given time. And some of this is about the same thing, right? Private networking, reaching other folks in your cloud on-ramps. Specifically with the cloud providers, we have the on-demand where it would show up in your cloud portal, right? Your Amazon console or your Google console within moments. We also offer a dedicated type offering where the on-ramp, the interconnection between our network and the cloud service provider is dedicated just for your use, right? It's a little bit more on the traditional model. But since we're a fabric, so to say, if you were to have a port here in Phoenix and one in Atlanta and one in New York and maybe one in Seattle, all of those different interfaces connecting to the fabric would be able to talk to that dedicated on-ramp going into Amazon or Google, instead of having to hairpin it through one location. And by hairpin, if traditional model has a point-to-point service, say a wavelength going between data center and the cloud service provider, if you wanted any of your other sites or any of your locations to talk to it, well, they first got to send it to the A end. In our model, all the locations can talk directly, natively to it. So yeah, we do not provide internet services directly ourselves. That's one of the staples of keeping this completely separate from the internet. That said, we do have direct internet access or transit providers that are part of the fabric, right? So you can connect into them through a virtual circuit. So you have your port here in Phoenix, and say you wanted to get some traffic from NTT. You want to buy some service from NTT. You still have a business relationship with the transit providers. We don't resell anybody. We're completely neutral. But all you do is from your interface, you say, give me a virtual circuit and I want it to go to the transit provider. And then the transit provider on their side will go and land it in and configure it however they normally do. But the end result is you now have connectivity, you now have a service from that transit provider. How this really affects folks is it doesn't really fit the model here in Phoenix. As you heard John say, they got 35 different carriers here, right? But there's a lot of other facilities around the country that aren't near as fortunate to have that many carriers. Let's say I've chosen to go into, 55 Marietta in Atlanta, right? It's an underserved building by far. All my existing contracts, say with my carriers, their pop is in, across town or down the street. Old model says I need to go locate my stuff in the same building they're in if I want to continue my business with them. With this model, we remove that barrier. You go put it wherever you want and just do a virtual extension to them. So it's about control. It gives you control. The way PacketFabric does it, and obviously I can only speak for our network, all these services we provide to our clients, it's at a layer 2 level, right? And that layer 2 level actually sits on top of our own MPLS network, which that's kind of cool, but it's really not the thing. What makes this possible is all that sits on top of our own optical transport network. And we do it a little bit different than a lot of other folks. We're not in the business of running long haul fiber and having trucks to go and do fiber splices because some backhoe operator, missed the marker or something wasn't flagged. What we do is we partner with the myriad of long haul providers out there, the Crown Castles, the Zaos, you name it. And we use their line systems. And for us, we use what's called Spectrum. You might know it as Alien Wave, right? Whereas we control the optical transports, right? We go and say, hey guys, give us this chunk of your actual line system, and we'll pay them for that capacity, without going too far down that rabbit hole. But since we control the transponders on the optical network, it allows us to upgrade that capacity. As technology advances, we swap out the transponders, we're able to get more capacity in the same sliver of space. To put that in perspective, when we put a POP in, our base POP is usually multiple paths end by 200 gig, right? So even our smallest POP is going to have an east and a west, each one a minimum of 200 gigs. So, and as technology, like right now, I know we're getting ready to deploy what's called, I want to say PAM4. This is getting, we got a lot smarter optical engineers, but I think the PAM4s do 800 gigs per optic. So this is what allows us to scale. This is what allows us to deliver, whether it's 1 gigs or multiple 100 gigs on demand. Because we're so new and a different way of doing things, we're seeing growth across the board. I see a lot of growth with media and broadcasting. We're picking up financials. Enterprise, I would say up to your mid-cap, are starting to pick up, because it's about control and flexibility. Look, we've had 20 years of being indoctrinated in doing it the legacy way, right? I'm a buyer, I'm an IT manager, a CIO, CTO. I got to start thinking in February for contracts I'm going to negotiate and execute maybe in May, to have, hopefully online tested and put into production, before the Thanksgiving holidays, right? When a lot of folks go into a end of year holiday season network moratorium. So as the word is getting out and more folks are starting to understand and appreciate what a software-defined network means, we're seeing more and more interest and uptake. And we'll say this, predominantly what we see is people will dip the proverbial toe in the water. Almost every conversation starts with, I need to get to the cloud. I've got some hybrid cloud strategy. And they'll get an interface into the fabric and they'll get a connection into the cloud. And usually in short order, they're like, oh, well, hey, are you in this location? Are you in that location? And we see, once they get on the fabric in pretty short order, and I know this is sounding like marketing talking, but it's not. This is real life. We see growth. We don't see people leaving. We see growth. We have been selling publicly, I want to say PTC, January 2017 is when we made our big debut and we started commercially selling services. In that time, we've only had two clients leave us, and they didn't leave us by choice. They went out of business. We're going to have a push. I want to say I can't remember off the top of my head. It's either end of this week or end of next week that's going to enable automatic client-driven upgrades. I want to upgrade this port. Or maybe I started as month to month, but now I'm comfortable. My proof of concept is done. I'm comfortable using the service. Now I want to take it longer term. They'll be able to do this through the API or through the portal. They don't have to go talk to the Chris's of the world. We're happy to talk to them, don't get us wrong. Along with that, everything we do, like through the API or our portal, we expose a lot of information. things that a network engineer or the folks that are running your NOC or your support teams would find invaluable. What are the statistics on the circuit itself? Obviously, you're going to have yours, but what's going on the interface on the carrier side, right? Oh, something's going on, you know. Traditional model has you picking up the phone or sending an email or logging a ticket, and then you got to wait for somebody to pick it up. And hopefully that somebody can have access to the system and give you meaningful information. We're happy to take those calls, happy to answer those emails. We make the information available 24/7 via the portal, via the API. You know, am I seeing errors on my interface? Am I seeing the interface go up and down? We even expose, specific to a client's interface, any log messages that are generated on the routers themselves. Right? So it's about transparency. Not for transparency's sake, but transparency for what it allows you to do. You know, you, the business, you, the network engineer or the NOC person that's troubleshooting. It allows you to work towards that problem resolution a lot faster instead of waiting for somebody to pick up your ticket, waiting for somebody to give you an answer. You know, everything we do is designed to be quick, and not quick for speed's sake. You know, it's great. We can say, oh, hey, we can get you an LOA in 60 seconds. You know, these other guys can't. Yeah, that's cool. But what it really means is it puts you in control of when that 60 seconds is, right? You get to work it into your business plans, you know? Maybe, you know, yesterday you didn't know you needed it. Today you have a hot opportunity that you can capitalize on. You can go after that business instead of maybe no bidding it because, oh no, you know, it's going to take 60 days before I can get this connectivity up. So just some of my thoughts. And I just thought I'd pull this up real quick. Proofs in the pudding, talk about transparency. All of our pricing is on our public website. Our SLAs are on the footer of every public web page. All you can do is just you go in, decide what term you want, and it'll change. Like this is our point-to-point product. So going cross country, yeah, PacketFabric. Sorry, I was a little bit off. $680 a month, and that's just on month-to-month pricing. No, that's on 12-month. This is month-to-month. $800. So slightly off. This includes both interfaces and the bandwidth in between. All of our services are inherently resilient. They're not pinned up to any one path. So if there's some sort of underlying event that knocks out fiber, right? The proverbial backhoe operator, line card goes bad, optic goes, whatever. Somebody screwing around in the data center disconnects something. It automatically reroutes. So the time of the reroute is really dependent on the distance, but typically you're looking at about 50 milliseconds. So, which is fast enough for almost all applications. There are a couple out there that's not quite fast enough, in which case, you know, you get a second line. We had addressed latency, packet loss, and jitter, just a standard. For those that are more technical, you know, we're jumbo frame by default. Every interface, our point-to-points, 9096 MTU, our point-to-multipoint, our EVPL-based solutions is 9092. Packet Directs EPLs are 9096. Well, I appreciate your time. If anybody is interested in learning more about it, see myself or Chris. If you're interested in a demo of what the portal might look like, I'm happy to show you that as well. Thank you.